Hello students, in this video we'll see how to compute the probability that a pair of random variables resides in a rectangle from the cumulative distribution function of those random variables. If we're given x and y jointly distributed random variables with joint PDF, joint cumulative distribution function rather, f of x, y, of x and y, which we recall is defined by the following probability that x is less than or equal to x and y is less than or equal to y. Then the probability that x is between a and b, x resides on some interval between a and b, and y is between c and d is equal to fxy of bd minus fxy of ad minus fxy of bc plus fxy of ac. And we'll see a way to remember this formula without having to memorize it. So let's think of it like this. So the probability that x is between a and b, let's draw this rectangle. So here's the x-axis and here's the y-axis. Let's say this is c and then this is d, and this over here is a, and this over here is b. Then we have this point over here, this point over here, this point over here, and this point over here. So let's label these points. So let's call this point over here point 4. Let's call this point over here point 1. Let's call this point over here point 2, and this point over here point 3. So this, of course, BD corresponds to point 4. This AC corresponds to point 1. The AD corresponds to point 3. The BC corresponds to point number 2. Now, if we were to think about what the CDF is, so the CDF of B and D, this is the probability that x is less than or equal to b and y is less than or equal to d. What that probability will give us is if x is less than b, we can have all of these values over here. And if y is less than d, we can have all these values down over here. So what we get is we'll get this rectangle over this sort of box. So that probability will give us everything in this large box over here. And that's way more than the rectangle we want. So what we'll do is we'll now think about what happens if I subtract off a fxy of ad, that's point number 3. So at point number 3, what rectangle will we have? We'll have this rectangle, so the same height, but now we'll cut off this length over here. So what we've done now, by subtracting off number 4 and number 3, what's left is the original green area was this entire thing, and we've cut off that little sort of sub-rectangle. So now what we have is we have this long strip, and we still get more than just the rectangle over here. So we can see we get not only get the rectangle, but we get the part below it too. So to compensate for the fact that we now have this portion underneath here, what I'm going to do is I'm going to subtract off. Let's subtract off the BC term over here. So the BC term over here is going to subtract off not only this rectangle over this strip over here, but it's also going to subtract off something extra. We'll subtract off this portion as well. So I'll have the positive area, so I will have my, if I subtract off the 4 from the 3, so if I have the 4, subtract off the 3, subtract off the 2, I will have not only the area of my rectangle over here, which is what I want, but I'll have the negative of this region over here. Now to compensate for that, what I'll do is I'll add back in that region. So if I add back in AC, what will happen is that I'll take this point AC over here, and I'll add that probability back in. So I'll take that positive, that negative term over here, and add in a positive copy of that. And so that gives us the result, that what's left over is just the rectangle. So the way we can remember this is by the following relationship. If we have this rectangle over here with those 4 corner points, so this would be the point A, comma B, A, comma C rather, A, comma C. This will be A, comma D. This will be B, comma D, and this will be A, comma, or B rather. This will be the point B actually, so that's going to be a B. This point over here is BD. BD. And this point over here will be the point AD. If we draw the positive slope line, this line over here is the positive slope, both those terms get a positive sign. So the positive slope terms get a positive sign, and the negative slope terms get negative signs. So if you do the negative slope terms get negative signs. So we'll have the CDF at BD is positive, so there's a positive term over here. The CDF at AC is positive. The CDF at BD is negative. That's actually a BC, not a BD, so it's a BC, so it should be BC over there. So the PDF at BC should be negative over here, and the CDF at AD will also be negative. So if we see an example of this, here's an example. If the joint PDF of x and y is f of xy is equal to 4xy for x between 0 and 1 and y between 0 and 1. Let's check this is a joint PDF. Well, clearly x times y is positive, and when you integrate x, you get x squared over 2, so you get a half. When you integrate y, you get y squared over 2, so you get a half. So 1/4 will work. If I want to find the probability, let's find the cumulative distribution function, f of x comma y of xy will be the integral from 0 to x, the integral from 0 to y of 4uv dv du. So what I'll have over here is I'll have a v squared over 2, so I'll have a y squared over 2 and an x squared over 2 times 4 when we do this. And so we get a CDF of x times y squared. So once we find our CDF, we're able to find probabilities. So for example, the probability that x is between 1/2 and 1 3/4, and y is between 0 and 1/2 will be equal to, well, we'll do the plug in the 3/4 and the 1/2, and that gets a positive sign. So we'll have 3/4 times 1/2 squared with a positive sign. We'll do the 1/2 and 0 with a negative sign. The 1/2 and 0 will also get a positive sign. So 1/2 and 0 will get a positive sign. Then the negative signs will be 1/2 and 1/2. So 1/2 times 1/2 with a negative sign. And then 3/4 and 0. So minus 3/4 and 0 with a positive sign. And we can simplify this now. So this over here is going to be 3/8 squared. So that's going to be 9/64. 9/64, that's going to be 1/4 squared, so that's going to be 1/8. Or 8/64, so this will be 1/64 is your total probability. Thank you very much.